Hi everyone,
I'm Gabby,
and I'm Krista.
and today we'll be focusing on gravity and orbits by using the Gravity and Orbit Simulation Lab.
Today's learning objectives are 1. Students will understand how gravity affects the motion of planets. And 2. Students will understand how the mass and the distance between two objects affect the gravitational pull.
The purpose of this lab is to determine the relationship between planets and gravity and how it ultimately affects the planet's orbit.
However, before we continue with this lab, there are a few concepts that you should know beforehand.
Newton showed that objects with mass have a gravitational pull towards one another. The greater the mass the object has, the more it affects the other objects around it.
Also, the closer together the two objects are, the more the objects are affected by gravity.
Newton's law of universal gravitation showed us that F equals g times the mass of object 1 times the mass of object 2, all divided by r squared.
Where F is the force between the masses and g is the gravitational constant, and r is the distance between the centers of the masses. In this lab, one of the things we will observe is how changing the distance between the center of the masses affects the force between objects and the gravitational pull towards one another.
So let's now start the simulation. First, observe the Earth's orbit around the Sun with the presence of gravity. So make sure that where it says gravity, you click on.
Now, if we reset it and turn gravity off,
So now click off where it says gravity.
the Earth's movement changes. Why does this happen?
Well, there are always two forces acting on the Earth or any planet, gravity and inertia. These two forces will always be fighting against one another.
If we turn the velocity and gravity vectors on,
So underneath where it says show, check off gravity force and velocity force.
we can see that a planet always wants to move straight because of inertia, but because of gravity, it doesn't.
So ultimately, the reason why planets stay in this elliptical orbit around another is because of this constant battle between inertia and gravity.
Okay, a second key term that you should know is that gravity is basically the attraction of two things. So the closer you get to that object, the harder it's going to pull on you, and the stronger the attraction's going to be.
And like we stated earlier, based on Newton's law of gravitation, how do you expect the force between the Earth and the Sun to be affected when the distance between the two objects is changed?
If we move the Earth closer to the Sun, we notice that there will be a greater force acting between the two objects. This is because the variables r and f are indirectly proportional to one another. If we decrease the value of r, we are increasing the value of f.
This means that the force between the two objects gets stronger, making the Earth eventually crash into the Sun, which is bad.
And if we reset and drag the Earth away from the Sun, we notice that the Earth is not affected by the Sun's gravitational pull anymore, making it go off on its own course.
Let's just play that one more time. Okay, so there's also another variable that we can change. This variable is the mass of the objects. So if we increase the mass of the Sun, so underneath star where it's the Sun, our sun, increase the mass of the sun. We notice that the Earth also collides with the sun eventually. So why do you think this is?
This is because mass m is directly proportional to force F. If we increase the m, the force also increases. There is now a greater attraction between the two objects, making the gravitational pull greater, which is what causes the eventual collision.
On the other hand, if we decrease the mass of the sun, so now decrease it, we are also decreasing the force between the sun and the Earth. Now observe what happens.
The Earth goes off on its own path because there is not enough attraction between the Earth and the sun to keep the Earth orbiting around the sun.
So by changing the mass or masses of the object, you are also changing the force between both objects.
So this wraps up our Gravity in Orbits lab.
Thanks for watching.